Hey everybody, let's continue to work on Lab 1, the greenhouse. What you should have already is your hypothesis, your prediction of the outcome. So it would go something like this, like I think that the greenhouse will be blank, so like hotter, colder, the same. Ooh, I missed a word. Temperature than the outside because, and then your reasoning, right there. This is where your observations should go about weather and stuff from yesterday. And then number 3, you should be working on a diagram. So just like the systems diagram we did for 5.3, where you like identified your phone as a system or something like that, you're going to identify the greenhouse as a system. So identify and label the boundary. All right, some components that you saw inside. Maybe you saw some plants, some dirt, something like that. Draw those in there. Some interactions that they might have. There was like water in here. So kind of think of it like maybe like the spheres. And then inputs and outputs. So what type of energy is coming in and out? And then what type of materials can go in and out of the greenhouse. All right. If you need some help with that, you can look at, let me see if I can move, hold on, this here. You can look at this picture from inside the greenhouse. And this can help you with some of those components and things that are inside the greenhouse if you didn't have a chance to look at those yesterday. All right. So then we'll move to the next page, data. All right, it is time to look at this data. All right, we'll have to do some statistical analysis on that, some calculations really, and then we can go ahead and graph it, because if we had to graph all this data for every hour, we'd be graphing literally 100 pieces of data, and we don't know how to do that. So oops, bumped it. Calculations can help us out. So what statistic we're going to work on this is our class average. All right, so you're going to be calculating the average temperature for each class. Outside, all right, and then the greenhouse temperatures right there. So when we do averages, and we can kind of write that up here, we need to write our calculation. An average is basically we're trying to get like the middle temperature, find out what it is. So we're kind of looking for that middle temperature, something that's kind of in the middle. All right. And how we can calculate that is we can add all of these temperatures together. All right, we add those together, we get the sum. So we'll get the sum total. Sum of all temperatures, and again, sum means to add. Hi, Wyatt. Hi, baby. I see you. All right. And then we divide, all right, by the total number of numbers we added together, or numbers we added together. So how many temperatures? So here I added all these together, and I got the total of 134.3. Then I'm going to divide by how many temperatures. Now you can see here we have, well, 12 teams, but team number 10 didn't put in there, so that would be 11 different temperatures. So then we go ahead and divide that by 11. All right, so I'm going to divide by 11, and that equals, for this one, 12.209, all that stuff. And when I look at that number, a couple things. First of all, we only measured to 1 decimal place. So your answer should only be in 1 decimal place. So what we're going to do is we're going to look here. All right, this number here, this is 5 or lower. So this is just going to stay 0.2. So I can drop that off. All right, and I'm looking at 12.2 as the average temperature. Now, what I do is I double check my number. If the average is the middle, what I like to do is look for the highest temperature. All right, so I find the highest temperature here, that's 16. And then I look for the lowest temperature, and if I look for the lowest temperature, that is 10.4. And you can see we have a bunch in the middle. And what I look to make sure is that my calculated value for average is somewhere between the highest and the lowest temperature. And I check it, 12.2 it is, so I'm going to put that answer right there, so 12.2. All right, then what I do is I go ahead and calculate the greenhouse temperatures, and then I put that average right down there. And then I'm going to put it in the next data table below. So let me kind of go below here. And what the information we need there is the time. So this is first hour's data. So the time we're going to use for first hour is going to be 8:50 a.m. All right, and our average outside temperature, sorry, let me fill that in. See that there? Is we calculated to 2.2, or sorry, 12.2. See, I have to focus. Right, then I'm going to put this calculated value in here. Okay, then you are going to scroll through and calculate third hour's data, fourth hour's, and fifth hour's averages. So where you're going to find that data is if you look in your Google Classroom, that is going to be under class data. So if I go ahead and look there, now you don't have to write down the data for all the classes, just your own class. So first hour, copy down your first hour data, third hour, copy down your third hour data, fourth hour, and so on. But you do need to calculate the values. So you'd have to calculate the average temperature for third hour, outside, inside, and then record here. So look at that time. And I can even put the time right there. So the time's going to be about 11:10 a.m. for third hour. And then calculate that outside data and the greenhouse. And then here's your fourth hour data, which was 1 p.m. So we'll say 1 o'clock p.m. All right, calculate that data and put it into this chart. And then your fifth hour outside data and inside data. So that's about 2:20 p.m. So do those averages and then write that into this data table here, right? This is the data table that we are going to graph on the next page. If you have your data calculated, then we can go ahead and graph it. And this is pretty much like an XY chart that you see in math. So this is going to be our X column right here. So this is our X, our independent variable. So we're going to be putting time and then these times on your X axis, which is right here. So this goes here. And again, that's your independent variable. We'll talk more about that. And I'll just put it right here, your IV independent variable. And then these are your Y's over here. So our temperature is our Y, and we happen to have two different ones. So we're going to have basically two lines on this graph to plot. So here is a Y, and here is also a Y. So again, this is your Y. So we're going to have two lines that we're going to plot here. All right, so let's go ahead and take a look at this graph on the other side. That's on my legs. Yikes. So I kind of ripped these apart so I can, all right, see them here. So again, the data that you're going to be graphing is this right here. And so we have our X axis, that's going to be here, our X. Right, and this is going to be time. All right, and we did time in hours. So in parentheses, you can just put an H for hours. And then we have our Y-axis. That is here, our Y's. And that right there you can see is going to be temperature. All right, so again, here's our Y-axis. You can even write temperature. And that is degrees Celsius, right? Then you'll come up with a title that describes. Okay, and we have a place here for a key because again we're going to have two different lines. And I think probably one of the hardest things about a graph is trying to figure out how do I count the spaces. And what I like to do here is my X, I'm going to look, I said, okay, my earliest time is 8:50. And we'll want to leave a little time before, so we're going to probably start 8 a.m. would work. And then we want to go till at least 2:20, maybe 3 o'clock. So I kind of just, you can count it and divide, but we'll say here, we're going to start here at 8 a.m. I don't have to start at like midnight or anything because we don't have data for that. So I'm going to say 8 a.m. and maybe each line will be a half an hour. So 8:30, 9 o'clock, 9:30, 10 o'clock, 10:30, 11 o'clock, 11:30, noon. Okay, so now we're into the PM. So 12:30, 1 o'clock, 1:30, 2 o'clock, 2:30, and then 3 o'clock. And that gives us a little bit of extra space at the end, maybe, so we can make predictions that are outside of the data we collected. So that seems pretty good. So for temperature, all right, we're going to look to do the same thing. All right, it looks like our low temperature on this is 12. And again, we don't have to start at 0. And what I do too is I can look at some of the class data and kind of look to see how high we need to go. It looks like we need to go into the 30s. I didn't average it, but it was looking like that, and 30, ooh, even higher. Ooh, okay. So we need to go well into the 30s for temperature. So we can start at maybe 10 degrees and go up to at least 30, maybe 35 it looks like. Okay, so let's see. So we have to figure out how many spaces we have. And we can probably start at like 10 degrees. I don't think it got any cooler than that. So we could say that this is 10 degrees. And let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 spaces that we need to spread. And we need to go up to like 35. So like 10 to 25, so we have like 25 degrees that we need to divide between 18 spaces. So I can do a little calculation that gives me a good idea about how much each should be worth. So 25 divided by 18, all right, is 1.3, and I'm not going to make each one of these 1.3. I'd probably rather count by 2s. So I would go 10, 12, and you don't have to number all of them either. 14, 16, 18, 20, I mean, you can number it how you want, 20, 22, 24, 26, 28, am I counting this right? 2, so 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So you can do it like that. I don't know why I just lost count. But that looks like all the temperatures will fit in. All right, so the last step is plotting your points. So what you're going to do is the first set is going to be 850 and then your outside temperature. And what I like to do is one line at a time. So I would do all, in this case, these would be all pink. And I'll graph these points and then do a line in a color, and then I'll graph all these ordered points and then do a line in that color. So like for instance, 850 is just about 9 o'clock. So I go about to 9 o'clock and we said 12.2, so that's 12 and just about 0.2 degrees. All right, so I'll make my mark. You can do it in pencil if you want and then go over it in a color. All right, so then I make my first dot there. Then I go to 1010, which is just, sorry, 1110, which is a little after. I find that average, and then I make my dot there. I'm just making up the dots now. Then I go to 1 p.m. I find that temperature. I make the dot there. And then I go to 2:20, which is almost 2:30 right here. And then I make another dot, and I'm just making this stuff up. So don't copy me on this. All right, and then I can make kind of smoothly connect these. All right, put this in my key to say which one it is. All right, and then go ahead and do the other data that you've calculated, and you got yourself a fancy scientific graph.